It is now my pleasure to turn today's program over to Jamie Gettler, Director of Metalworking Innovation. The floor is yours.
Okay, Matthew, thank you. You can hear me okay and see my screen? So
Yes.
we're off and running. Fantastic. So good morning, everybody, and thank you for joining today's call. Obviously, talking about MSC MillMax. We've updated some content here and some of our metrics. We're excited to share it. Some of the impacts on your business as a customer or potential customer of MSC's. As Matthew had outlined a moment ago, my name is Jamie Gettler with MSC 20 years. My responsibility at MSC is metalworking innovation. And the idea within the department we operate in is to identify those types of services or solutions or products that we believe and know that would be beneficial to American machining and manufacturing businesses. So MillMax is the first of several innovations that we'll be releasing to the marketplace, and we expect them to have each of these innovations to have quite a significant play quite a significant role in improving the prosperity and productivity of your machining business. I'm going to go ahead and get started with the presentation at this point, and we'll go through here. We're going to talk a number of different ways about MillMax. What it is, how it works, what you can expect from it, why we're doing MillMax, and what it's doing not only for American businesses in terms, as I mentioned a moment ago, their productivity and prosperity, but also what it's doing, for the Department of Energy and with our friends at Oak Ridge National Laboratory and some of the imperatives associated with that. Also, as Matthew had outlined at the outset, please, chat questions over. Ron Efferding has joined me. He's part of our innovation team as well. He will interrupt me as we're going along. So feel free to ask questions as we move along, and we'll answer them. Our best webinars, and we've done many of these, are when we have a ton of questions and curiosities and clarifications from the audience. So please feel free to do so. So the objective, as I said, is to showcase just how and why MSC MillMax works. We're going to share some real-world examples of performance improvements, a couple of them individually, but also in aggregate, and outline how this is transforming businesses just like yours. The foundation, for all of what we do at MSC and certainly within the innovation team is steeped in the fact of three main what we call primary concerns of American manufacturing businesses. This was a survey that was done a few years ago by a company called Clifton Larson Allen, and we recently asked these similar questions to a MSC Customer Advisory Board and found that the same three items from a few years ago are still the primary concerns of American businesses, and they are as follows, and you see these on the screen right now. It's the ability to withstand pricing and margin compression, or to improve profitability of your business. So if you're more profitable, you can be more competitive because of your cost position. That allows you to withstand the pricing and margin compression maybe put on you by your customers, but it also allows you to potentially look to reshore supply chains from overseas, putting the U.S. in a position to have a more independent supply chain, as well as the overall profitability, of course, of your business. The second thing is that businesses like yours want to grow year over year, and there's two really ways to do that in manufacturing. One of them is if it's a machine shop, whether it's a job shop or a production shop, you can go buy more equipment. If you have the floor space and you have the capital, you can go buy more equipment, and by virtue of having more equipment, you can make more parts. Pretty simple. The other way to do it is to improve the productivity of your workforce, but also the capacity and how much you're running through these pieces of equipment. Making good parts, less scrap, but cycle time reductions become critical there. So the second way is if you can make more parts on the existing equipment that you have, you don't have to outlay that capital or infringe on any floor space or potential lack of floor space that you have. So that's number two. And then the third is doing these things in the face of this ever-growing manufacturing skills gap. So can we improve our profitability, our competitive nature as a machining business and grow year on year, but do so in the face of this challenge of having skilled workers out there. So, what we do at MSC is we really focus on those things and try to find ways to help you in those regards. And as I said, the same thing falls in line here in the innovation team. As you may know, MillMax in and of itself is part of a cooperative research and development agreement that we have worked on with Oak Ridge National Laboratory, which is part of the Department of Energy. Interestingly enough, what we share on this particular slide is, what you see on the left-hand side is an executive order that was released a few years ago that outlined some of the challenges that exist within the domestic manufacturing marketplace in the U.S. and how that has made us supply chain dependent on with foreign countries, how it challenges our ability to be a more safe and secure homeland and to be a more robust manufacturing economy. Those findings were released in this executive order. And the challenge was for manufacturing leadership in America to find a way to improve in these regards, and through training and through technology and innovation. Similarly, we know, as I just outlined, for manufacturing businesses, those same things that mean, better parts, more accurate parts, overcoming the skills gap, using artificial intelligence, using Industry 4.0 endeavors, being more productive, generally speaking, also help our customers become more prosperous and productive. So interesting that the same things that we're trying to accomplish with MillMax have somewhat of a nationalistic endeavor in being able to help with that executive order and addressing that, but also the very same things help our customers become better. The relationship with Oak Ridge has been fruitful, and it'll continue to be for MSC and ultimately for our customers. And you read some of the details of it. It's a pretty interesting story. It was on the cover of Modern Machine Shop back in October of 2020. I invite you to read it. It's a really great story, and it outlines some of the things that we'll share today and maybe even some of the further details. So from a national and a commercial strategy, some of those things that we're seeing with MillMax are as follows. We're finding a higher material removal rate. And later in the presentation, I'm going to share with you what some of those metrics look like. And they're pretty jaw-dropping metrics that MillMax is offering up in terms of these improvements. Faster setup. We can include faster setup to mean, less scrap, knowing instead of guessing in terms of your speeds and feeds and how you'll operate these milling tools on that piece of equipment for that particular material. And potentially programming too, knowing what cutting strategy. Is it a full slot? Is it a profile cut? Is it ramping? Is it tricoidal milling? It could be any of these different choices, and you'll know at the outset the ideal strategy. So faster setup is certainly within reason. Greater capacity. We're finding significant cycle time reductions on average in all materials. Longer tool life is in a lot of cases a byproduct of us helping eliminate chatter from the milling operations that you encounter. And as I said, that knowing, not guessing, is saving critical hours of getting more jobs on the machine and not scrapping parts. And so, for that manufacturing impact for the United States is supply chain independence, greater agility, improved resilience, sustainability, lower energy usage, quite frankly, if you're getting it right the first time, and improved homeland security. But those same things in the middle of the screen are also improving competitiveness, higher profits, higher revenue, less downtime, less scrap, bridging the skills gap. So that's why with MillMax, we couldn't be more proud to introduce this kind of product, into the United States businesses and to our customers. So let's talk about, I just mentioned chatter, and, MillMax is definitely in the business of dealing with situations where customers' operations either will be chattering or potentially are currently in a chatter situation. What we know is that vibration matters in any type of machining, but in milling more so, because the physics of milling would show you that a cutting tool or a milling tool has multiple teeth. Some are in the cut and some are not. Now, the drilling has multiple flutes, but they're all engaged all the time. In milling, that's not necessarily the case. And because of that, you have deflection that happens. And we're going to see that in a moment. But even if we just look at a spindle of your machine, and we were to tap that, and I'll show you how that works here in a moment with the MillMax video. If we were to tap just the spindle of your machine, of course, it's going to vibrate a little bit and wouldn't be able to see it with the naked eye, but it can be detected. You add a holder for an end mill or a face mill or a shell mill to that, that would vibrate at a different frequency, but they're connected. And so now you got to deal with multiple frequencies happening. Now you add a cutting tool to the mix, and the ability for those things to find the stable speeds is very difficult. And today it requires that trial and error I mentioned a moment ago in order to identify how does this system of a spindle, a tool, and a tool holder want to run in conjunction with one another. I use the analogy from time to time of a washing machine on a spin cycle, and sometimes that load within the container is balanced, but you hear that rattling. It's essentially chatter. It's essentially, vibration that's happening because it's not a stable speed at a certain RPM. But then it goes faster and faster, and it kind of goes away. And then maybe a little bit faster, it seems to come back a little bit. And you do one of those things where maybe you want to get up out of your chair and go fix potentially this washing machine and see what's going on, but then it ends up being fine. In a lot of cases, it's just like this milling machine I'm showing you, this milling setup, where some speeds are stable and some are not. Ceiling fans would be another example, or a rattle potentially as you're driving your vehicle in some cases that we've all probably experienced. Same kind of notion. What MillMax does is we need to identify that first. So chatter, of course, you can see it, and this is extremely slow motion visual of it. The top item, as you can tell, using that red line to help guide, as you can see, that milling tool is moving backwards and forwards. And you can see the chatter is causing different size chips. And as a result of that, you're going to have bad workpiece finishes. You're going to have substandard tool life. And depending on how much of the spindle load is being taken on, it can run roughshod on spindle and the life of that spindle. The bottom one, shortly after being tapped using MSC MillMax, you can see a much more stable cut, consistent chip formation, and that's what you want. With that being the case, longer tool life, better surface finishes, less scrap and less wear and tear on the machines, and in the overwhelming majority of cases, much faster. Obviously, surface finish comes into play in a big way when it comes to chatter versus not chatter. And so our ability to identify how to help you eliminate chatter from your milling operations, plays a role in a significant amount of different improvements for your organization. At this point, I'm going to switch to a video that, Ron and or Matthew, whomever is off, can tell me, as long as you can see it and that the sound is coming through. But I'm going to play this MillMax video, and I'll stop strategically at a couple of points to point out a few things and highlight a few things. What I can tell you is that it's at this part of our presentation that we normally have an abundance of curiosities or questions or challenges. And again, please feel free to add them to the question list, and we'll be prepared to hit them. So Ron, if you can let me know that you can hear this and see it, we'll off and running.
We're good.
All right.
We don't make milling machines, milling tools, or milling software. We just make them all mill better. Here's how. Unlike other machining operations, where the cutting edge never leaves the workpiece, milling has hundreds of individual tooth impacts per second, generating forces that cause deflection and vibrations. Like this 75-pound anvil, every tool is flexible and vibrates at its own unique frequency.
So right off the bat, we're showing you here, what you can expect from a MillMax visit or consultation, as we call it. So what you have here is a what's called an instrumented hammer. There's a cable on the bottom side of that hammer that's attached to our metalworking specialist's laptop. And this plastic tip on the hammer ensures that there's no damage to be placed on this tool, but we're going to tap that tool strategically a few times in the X direction or X axis and a few times in the Y axis. The computer is going to tell us, did it capture and was it able to measure, the amount of pounds per square inch that we struck that tool with. Consequently, we're capturing the vibration of that system using this accelerometer. Of course, you can see the cable there that is also attached to that same laptop. While we're doing that, essentially what's happening is if it's me that's applying this pressure to the tool, it's saying, okay, Jamie hits the tool this hard, and when he does, this system vibrates this much. And it allows us to identify through that vibration and through that measurement, what are the stable speeds that this system, this tool, in this holder, it looks like obviously a shrink fit holder, in this spindle of this machine, how do they want to run in conjunction with one another? That's step one. The next part is, hey, what material are you machining? How deep are you cutting? How wide are you cutting? What is the horsepower of this piece of equipment? What are the max RPMs? What's the torque curve? All of that stuff is taken into consideration in this advanced computer software program that allow us in a matter of seconds, we'll say a matter of minutes for an entire test, but a matter of seconds to publish a dashboard. And I'll show you what that looks like here in a moment as well, that tell you the exact stable speeds to help you optimize right off the bat.
Why is this important? The tool point deflects and rebounds at a frequency determined by the flexibility of the tool holder and spindle. You also have the tool impact frequency determined by the number of teeth and spindle speed. You have to get the timing of these two frequencies just right. If you do, each tooth is cutting equally, so tool life, productivity, and quality are maximized. If the timing is off, a tooth arrives too early, undercutting and throwing off the next tooth. It arrives too late, exceeding the programmed chip thickness, leading to premature tool failure, poor surface finishes, and possibly scrap. This timing mismatch keeps getting worse and leads to chatter.
Okay, so we've all heard that sound before. You don't want to hear that sound, but sometimes it's a reality, or sometimes that's what happens, and MillMax looks to help us avoid that, to help you avoid that. I stop here, not because I need to show you what chatter is, but there's a microphone that you can see, a larger microphone in the corner of the screen here. And part of the MillMax kit that our metalworking specialists carry with them allows us the opportunity where if you as a customer have existing chatter and you can see it in the surface finish or you can hear it, and we want to resolve it, we actually don't even need to stop the machine for that short amount of time to tap the tool. Sometimes we can listen to it. And so we carry a much smaller microphone in our MillMax kits that allow us to listen to the chatter that exists in your piece of equipment with that particular operation. We listen to that for a given amount of time, 15 or 30 seconds, and then we add into the software some of the pertinent parameters. What RPM were you spinning at that point? How many inches per minute were you feeding? What machine, RPM max, what material, a couple other bits of information. And just by virtue of listening to that sound file, we're able to tell you in a matter of seconds the stable RPMs that would help you fix that chatter or eliminate that chatter. Taking it a step further, I'll share with you a little bit later when we talk about, it's called Harmonizer. We talk about this Harmonizer component of the MillMax kit, how at your facility, I know the pandemic is in many cases allowing us to visit more customers and be on the shop floor. But we had a customer recently that was able to record the sound of chatter on their mobile device, text it to our metalworking specialist who in the comfort of their own living room, were able to report back to the customer in a matter of seconds how to fix the chatter. And not only did it fix it, it transformed their operation. So some pretty cool stuff that we're able to do with it.
Without knowing the tool's frequency, the common response to chatter is to slow down the spindle speed, vastly underutilizing the capabilities of your machine and tooling.
Important to note here the range of sizes that we can use MillMax in your facility with the standard kit that our metalworking specialists, and there's 140 of these folks nationwide, by the way, we are nearby with the MillMax service and MillMax kit. 3/8 of an inch on the bottom side, up to 6 inch in diameter with the traditional kit that we carry with us. And as you can see here, Indexable works just as well in Indexable as it does with solid tools as well.
As we said earlier, every different tool, tool holder, machine combination vibrates at its own unique frequency. The challenge is that there are billions of potential combinations. MSC MillMax measures the frequency of each tool and instantly generates a dashboard that calculates the precise stable speed, feed rate, width, and depth of cut for maximum performance. It also determines the best speeds for surface finish and accuracy. You will always know where to run. This patented and proven technology is in use at the world's largest manufacturers. It is available exclusively from MSC's trained and equipped team of metalworking specialists. Contact your MSC representative for more information.
Okay, so that's MillMax and how a MillMax test is administered. Ron, any comments or questions from the audience at this point?
None so far, Jamie.
None so far? All right. Remember, folks, feel free to submit any questions or curiosities that you might have regarding MillMax. So you should be able to see my PowerPoint again, Ron. All right?
Yes. Yep, we can.
All right, wonderful. So, this is a leftover question that we used in our last webinar. We had Dr. Scott Smith from Oak Ridge National Laboratory, who's in the team, or the group leader, I should say, for intelligent machine tools at Oak Ridge. And we had asked Scott, how does MillMax, or impact testing as it's known in some circles, help machining businesses avoid chatter? And so you just saw, in the video, how a MillMax test is administered. And you can see here, pictures of us administering a test, but it's also based in the fact that these multitude of stable speeds exist that a tool wants to run in a particular tool holder in your machine of choice. And you can see here that these red areas, and the axial depth of cut on the left-hand side of this graph, and then the RPMs at 7,000 RPMs at 1 inch, we'll call it, is a very stable speed. There's a nice heavy fat area of stability that exists here, where most folks would not find that. And I'll show you how that's difficult using the traditional trial and error methods. But there's a multitude of stable areas that you're able to operate this tool. And most times what we find ourselves and with customers, there's a lot of room for improvement. We take these, what's called a stability lobe diagram, that shows the safe areas to operate, the unstable areas to operate, and then what we call the warning track is some of this yellow that's kind of a warning, if you will, that says, all right, you're going to start to hear a little bit of chatter and you're going to start to get some bad finishes. And red is essentially, you're probably going to either create chatter or break this tool at some point soon. Finding these stable areas is the key. We find about 90% of our customers are operating in this lower stable zone, when in actuality, there's some other stable areas. This is somewhat of a smaller one here at 11,000, but there's, a nice heavy one here at around 12,000. This is the dashboard that we give to you as our customer after a MillMax test is administered, and it gives you all of the stable speeds that you can operate within. In a moment, I'm going to show you a live dashboard, and this, what we call slider, allows you to move the width of cut and depth of cut around. And as we do that, you'll find that this dashboard refreshes itself instantaneously to say what you can and what you can't do with this tool in this machine for the material that you're about to work with. So let's take a quick look at that dashboard. I'll show you. here. This is a real dashboard, as you can see, that we created for a customer of ours. And you can ask this dashboard, you know, how it is that you might want to find different ways to machine this. In this case, it was aluminum in a Makino A51. Every machine's going to be a little bit different. And of course, we have a unique holder here, and we have an end mill that we've identified. But this is telling you how you can find the stable areas for machining. A variety of different widths of cut, depth of cut. And as you know, from your machining practices in the past, the smaller width of cut and depth of cut that you take, of course, there's a multitude of RPMs that you can operate when you're only taking that much of the cutter. But your material removal rate is somewhat small here. So, you know, is that machine capable of taking more? A larger width of cut, a larger depth of cut. Your machine is identified here uniquely. This is not a cookie cutter dashboard. If your machine had 10,000 RPMs, the max on this tachometer would show 10,000. This particular piece of equipment had 14,000. So if we said, hey, we're doing some roughing, we want to find a stable area that's going to really remove some material. You can see here that our material removal rate was over 4. The trial and error methods that we all have used in the past have a range of surface footages, you know, from a bottom end to a top end. And it's a guessing game. We typically go to the middle surface footage. So if the bottom end was 1,000 and the top end was 2,000 surface feet, many folks would go to 1,500 and then listen to, you know, the sound of it, look at the load meter, a number of different things to say, hey, should we try to turn this up a little bit? Or that doesn't sound good. Human nature is to turn it down. If we did that, you may start here and it doesn't sound so good. Most people, particularly in materials other than aluminum, would say, you know what, we need to turn this down. What I can tell you is dashboards for all different types of materials, whether it's titanium or whether it's Inconel or whether it's hardened steel, have a multitude of stable areas like this that you may be able to operate in. And frankly, the only way to know that and to know that with any certainty is the utilization of this type of technology. So this is what we offer up to our customers. You're able to use all of these parameters to help you with your programming and also help you to eliminate scrap, that trial and error of trying to figure out how this tool is going to run, and while you're doing that, potentially scrapping some parts. We also give you access to an accuracy monitor as well as a surface finish calculator. The lower the line or the point of the line, the better the surface finish that you're able to achieve. And you can work with this dashboard if material removal rate and speed weren't necessary and weren't your most important characteristics. If surface finish was, you have the ability through this to do that as well. Okay. Ron, no questions still?
No, sir.
All right. Okay. I think over time, the probably 10 of these that we've done, we're incorporating those things that typically folks are asking. So again, if you have some and we haven't addressed them, you know, please do. The other way to look at this is the choice is yours. It's interesting that you can choose the faster speed and the shorter cycle times. You know, physics and material properties would tell you the faster you go, the less your tool life can be. But you have that choice. If you really want speed and to make as many parts as you can in a given time frame, you have that option, and we can help you monitor tool life with it. Or you can go a little bit less speed and improve your tool life. Or you can elect to go with just a better surface finish. So, you know, the choice is yours, and all of that information is available to you in real time on the dashboard that we provide to you. We talked about Harmonizer before. And the fact that we're able to take a sound file, this is what it looks like on our cell phones. When we take and we listen to that chatter that exists in your equipment, whether we're doing that on site or whether we're doing that through a text or an email of a sound file, and able to get back to you quickly with the response to help resolve that.
Hey, Jamie, we have a question.
Sure.
Can the dashboard tell you what the optimal parameters are to maximize metal removal rate?
Answer is absolutely it can. So, you know, it will take, it's not going to tell you outright at this point in the software version that we've created. But what you would need to do is just monitor that. So right now, you know, we're at, well, let's go to a stable area first. So let's keep an eye on this. You know, we got a 2.1 here in a stable area at 7,000 RPMs. This is where your determination of a cutting strategy can come into play, finding a stable area where you're removing the most material. Let me find a higher one. So we're opening up a stable area here. Let's move the speedometer or tachometer here, and you can see where it sits. And it's through that kind of interaction with the dashboard that you can find it. But as of now, it's not, hey, click here to see what the top MRR is. You need to kind of locate that using the cutting strategy that you're comfortable with. But the answer is yes, you can do it. It's just working with you and with the dashboard together to make that happen. It's a really good question. And potentially something that we look to add to our dashboards in the future is show me the max MRR that's possible. Good question. Any other questions, Ron?
That's it right now, Jamie.
Okay. All right. That was a good one. I haven't had that one before. I like that. And hopefully we have who asked that question. So I'd love to follow up with them when we get that. So aggregated results from our MillMax testing. You can see here, folks, that the numbers are they really are, as I outlined before, jaw-dropping in nature. So machine speed, we like to talk about the machine speed or the RPMs on the spindle and say, listen, RPMs isn't what necessarily is putting parts out the door. It's material removal rate more so. We'll talk about in a second. You know, RPMs, the reason we put this on here is we're basically we are doubling on average the RPMs that our customers are spinning the tools when they use them. Why is that important then if we're going to show this? Well, maybe you bought a machine with 20 or 30 or 40 or 50,000 RPMs and you're not using them. You know, getting up to those higher speeds can be intimidating sometimes. MillMax will let you know what that machine is capable of doing for the material that you're about to machine. So on average, and we're at the point, folks, where we're hundreds of tests in all different materials, anything from aluminum to super alloys to stainlesses to harder materials, softer materials. These are all averages across all of those, across production environments, job shop environments. And on average, we're walking out, if a customer is at 3,000 RPMs with an existing operation, on average, when we walk out, you're at 6,000, is basically what we are seeing with that. So that really appeals, again, that if you have a lot of RPMs available at the spindle, and you can make better use of the investment that you've made, because those kind of spindles, of course, as you know, can be quite expensive. Feed rates. So you start to get more, you know, pertinent, we'll call it. And that's how fast this milling cutter is traversing the workpiece. On average, we are a little bit more than twice or double what our customers' feed rates are when we start the project. So if it's an existing operation and you're machining Inconel and you're at 7 inches a minute, when we leave there, you typically at a little bit over 14 inches a minute. If it's aluminum and you're at 200 inches a minute, on average, when we leave, we're finding that our customers are at 400 inches a minute. Again, is a little bit probably more important of a metric than RPMs, but not quite as important as material removal rate. Again, unless you're in a final finish and the surface finish quality is the most important thing, all others, material removal rate predominantly is the most important, and we find that from our customers. That is, of course, how fast am I going, how deep and how wide. And essentially what that equates to is cubic inches of material that's being removed per minute. And we are doing that by a factor of 3 times. So a 200% improvement on what our customers' MRR is our average, again, across hundreds of tests and all the different materials that we are. So, you know, if you're at a material removal rate of 5, when we leave, you're closer to 15 when we leave. And what does that mean? Now you're getting into some metrics that are really relevant and real dial movers, no pun intended when we talk about our dashboard, that are really important to your operation. That then equates directly to cycle time. And you can see on the right-hand side, our average cycle time reduction is still right around 40% reduction. So if your milling cycle, pocketing work that you're doing is 10 minutes, when we leave, it's going to be closer to about 6 minutes. If it's, a small run job, that's going to help you improve your profitability. If it's a production job, the amount of money and time that you're going to save, the amount of more parts of supply and demand was such that if you make them, you would sell them. Now you're starting to get into some really significant dial movers and some critical business results. Capacity gained on average is 80 hours per successful MillMax test. So what that means is, by virtue of going this much faster, whether it's a job shop or whether it's a production shop, we're finding that we're giving our customers back 80 hours of spindle time. And that's because you're able to complete your jobs that much faster based on what we showed you. And what that does is that allows you to add more work to that piece of equipment. More work means more revenue. More revenue means more profit, and without adding new equipment. So there's a lot of really great benefits to these results that we're seeing on average with MillMax. There's a slew of other potential benefits. I created a new slide that I'm going to introduce here in a second, that in a couple slides that'll outline this a little more specifically with the recent test that happened here. But you can see here some other things that we don't necessarily document in terms of cost avoidance or cost savings. Is you didn't have to go and buy more equipment to grow your business, because we're showing you these capacity gains potentially. Equipment wear and tear. Because we know that we're operating the spindles in these critical milling operations where chatter, again, causes issues longer term with the performance and the sanctity of that spindle, you're not going to have that as much. So your spindles and your machines will last longer. Post-operation process elimination. So what we're talking about there is, hey, look, with the dashboard, we're able to tell you, here's how you can maximize your surface finish using this tool and this material. And if that finish is good enough, and you can potentially eliminate a process afterwards of potentially buffing or otherwise to get the finish that you desired. Additional product savings. So if you were indeed buffing or somehow polishing, you could eliminate those products in some cases, not every case, in some cases. A lot of cases we have cutting tool expense reduction. And so you're going to use less cutting tools, because if they're not chattering, then they're going to last longer. And then the overall optimization time, again, average end mill test, we can vouch for this, but Cutting Tool Engineering documented this several years ago, that the average end mill test is about a 3 to 8 hour time frame just to find stability, not even optimization. We're finding optimization for you in about 15 minutes of machine downtime, which is extraordinary. Roman, is there any questions?
Yeah, we've got a cool question. If you go back to that dashboard, the live dashboard, it'd be easy to answer this one. Can the dashboard tell you, or I'm sorry, is there a machine tool database
that supports the dashboards? Absolutely.
Yeah.
So we can go ahead.
I thought maybe the machine model would show that, Jamie.
This here? Yep, absolutely. So we have a database of hundreds and hundreds of the top makes and models of machines that exist in the marketplace. So let me start. There's going to be two ways to look at this. That's a really great question once again. So we know the RPMs, we know the horsepower, we know the torque rating and torque curve of a variety of Makinos, Haas's, Akumas, Mazaks, so on and so forth. Sometimes you have a custom piece of equipment. Of course, it would not be in our dashboard, and so we would inquire with you, hey, what's the horsepower? Can you get me access to what the torque rating is for this thing? What's the max RPMs that you have? A couple bits of information we manually can add in. So this isn't relegated only to standard makes and models that exist in the marketplace. You might be running an RTM that's completely unique and has a fixed RPM, and we can deal with that separately. But all of that is available for us to really make this dashboard precisely and uniquely customized for your equipment. It's a good question. Any other questions, Ron, right now?
That's it right now.
Okay. All right. Thanks. All right. Here, and we'll go back to this slide here. We're good with, we'll have some time for questions at the end. This is what you can expect, folks, from documentation of your test. In this particular case, you see a $9,300 profit improvement for this customer. What we'll do is we'll line up your current state. What was the case when we got there, if it was an existing job? And then what we found after using MillMax that you were able to do in a more stable, faster, successful operating parameters. And we'll compare that, and we'll hand this to you to say, okay, by virtue of this 15-minute test, if you have to make this many of these parts, then you're going to improve your profitability by about $9,300 just from this short test, just with by virtue of using MillMax. Okay. Here's a smattering of different successes in a variety of different ways that we're looking at them. The color coding on these ones obviously is ISO in reference. So the blue is steel, the yellow is stainless, the red is cast iron, the green is non-ferrous, and the brown is super alloys. And the purpose of this slide, folks, is sometimes with tap testing, folks believe that it's really good for aluminum, but maybe not for other materials. And I'm here to tell you that our testing in any material is showing success out there. So if you're machining compacted graphite iron, or you're machining 316 stainless or 416 stainless, and you're considering in looking for optimization of how you're operating milling tools in your facility, let us know. Let us get involved, do a demonstration, and help. And we'll talk about the process and next steps here in a moment. But you can see that the improvements that we're witnessing and experiencing are pretty enormous. I really like this compacted graphite iron one, or CGI as some would call it, because at a truck engine manufacturer, of course, there's runoff after runoff and so many tool trials that are done before this thing goes into production. And we showed up and we talked about MillMax with this particular business and shared with them, what the possibilities were and what we were seeing out there. And they were certain there wasn't going to be much room, if any room at all, for improvement. In less than 15 minutes, we were able to improve their material removal rate by 64%, just with that simple tap test. And they were blown away. And what it was there was a whole other stable zone at a higher RPM and ultimately a higher feed rate, as you can tell. So great results across the board. This is the one I was mentioning a moment ago. Going to take a stab at this. And when we deliver products or services out to the marketplace, what's the total value proposition potentially for a customer? So you can see in this particular case, I'm in Pittsburgh. This actually happened in Pittsburgh. Jason Beatty is our metalworking specialist here. He was actually on the cover, ironically enough, of the webinar pamphlet that you got. But Jason ran this MillMax test here within the last week or two. In 4140, not a huge run, 50 parts the customer had to machine. And when Jason showed up, the customer was running a 4-flute tool with 367 surface feet. You can see some of the metrics. The tool was $162 end mill. Their material removal rate was slightly under 4 cubic inches a minute. You can see their feed rate, and they were getting about a half a part per end mill with this large pocketing operation that was being done on this. And the cycle time cost of the milling itself, so how much it cost that customer to operate this end mill and this part with the cycle time and everything being involved, was about $52,000, slightly above that. We came in and we tapped a different tool that Jason recommended. And when we do this, folks, the idea is that we're going to introduce what we believe would be a better tool for the operation, in some cases a better tool holder for the operation. It's because we're getting smarter over time by applying this technology. And so Jason introduced a 6-flute tool, 900 surface feet, 3.5 thou per tooth. We took the material removal rate from 3.65 to 5.37, the feed rate from 15 inches a minute to 144 inches a minute, but got 2 parts per tool. And so the cycle time cost, because we were able to do it so much faster, went from 52,000 down to 7,500. That total cost savings that, essentially any of our customers, including, you folks on the phone, that you would accept is, this is putting $59,000 of improved profit in our pockets because I'm able to make these so much shorter based on your burden rate. There was a $13,000 less in end mill spend associated with this, and the tool change savings, of course, with having to change tools less often. But it gained 450 hours of capacity on these machines, or allowed them to add that much time. This is a large, work piece. But actually, if I take a shop, and I just use some ballpark numbers, yours may be higher or may be lower as a business, but work with me on this one. Is we'll say a $5 million shop in terms of revenue. If you divide that by 253 days, so let's say they're running 5 days a week traditionally, and running 1 8-hour shift, so 9 hours, but with lunch, we'll call it an 8-hour shift, that their average revenue per hour is about $2,500. If we give back 450 hours and you apply new work to that 450 hours, that potentially is $1.1 million of new revenue that could be added. We don't take credit for this. We don't call this out traditionally, but that, what are you going to do with that 450 hours is up to you. It could be a new source of revenue, a different customer, another job, right? And again, without buying new equipment. And if you're making 10% profit margin on that particular work, that's $110,000 of improved profit, all because of a simple tap test on a milling cutter. Again, these are noteworthy things that we'll share. We're not going to claim them as cost savings because you might use that time for training unskilled associates. You might use part of that time. That's up to you, but showcasing that that's available. You have the trial and error time that's saved. A minimum of 3 to 8 hours is what we found to try to figure out how this end mill will work. But we're doing it in 15 minutes. And so, you might find that the difficulty right now, finding programmers. If you want to grow your business, you might need to add another programmer. If we're able to help on the milling side with finding those applicable and optimal speeds and feeds quickly, allowing you to consider a full slot versus tricoil versus plunge versus any of these other things, really can help a business with an overall value proposition. Again, all steeped in MillMax. So, Ron, is there a question?
Well, we actually have 2, Jamie.
Okay. All right.
The first one is, can you use MillMax to tap live tooling on a lathe?
I'll let you answer that one because I know you know that one.
The answer is yes, you can.
Absolutely. So what we tell customers, and whoever asked it, again, is a great question. What we're seeing in the American machine tool marketplace is a real leap in mill turn and multi-spindle type machines because of their flexibility and capability. So we expect to see more and more of the need to tap the spindles of live tooling and those types of machines. What I would tell you is sometimes there's a little bit less horsepower on those spindles, sometimes a little bit less RPMs than we would see in a traditional vertical or horizontal machining center. The improvements, we can absolutely optimize them. They're probably not going to be as significant as you would find in a traditional milling machine, but they absolutely are perfect candidates for optimization nonetheless.
Jamie, this next one goes back to the machine tool database. Mm-hmm. Is the relevant information provided for each machine only the RPM and spindle taper, or are there other variables for each machine's design in the algorithm? Yeah,
so certainly horsepower, certainly the torque curve, the connection. We note the connection. A Cat 50 is probably going to be a little bit more sturdy than a Cat 40. tool holder, and it also depends on the projection of that particular tool holder. But if we go back to the machine, there's really just a few variables of things that we want to know, and it's to help us understand what the limits, how we can operate this particular end mill. So you would think we would need to know a lot more potentially about the machine, but the RPMs and what the horsepower is and the torque curve are the most important things, I would say. And again, that allows us to know what boundaries that we need to work within. I might show you that that end mill that you're running, if I overrode the RPM limit, could go 55,000 RPMs, but if you only have 25,000, what do you care if it could go 55,000? We need to know what it will do for your machine. So those few prerequisites are really the most important things that I just noted. This is, again, a really good question. Any others, Ron?
That's all we have right now.
Okay, a few minutes left. So if you're interested in MillMax is appealing to you, what I would tell you if I was in your position, and I've told hundreds, if not thousands, I guess at this point, of customers, is I would want to see it to believe it, right? Let's do a demonstration at your facility, no charge demonstration. What I would ask is that if you're interested, our sales team will be reaching out, to you. If you have a sales rep assigned to you or a business development person assigned to you, they'll reach out. Identify a tool, whether you're a job shop or a production shop, that you use on a regular basis. If it's a job shop, you might use, this 1/2-inch 3-flute end mill on a variety of different jobs and maybe a couple different materials, but that's a tool that you run all the time. It's those tools that are the ones that we can find the most improvement and have the biggest impact on your business. Absolutely, we can optimize, a 7/16 end mill that's sticking out of the spindle 6 inches, but the ability for improvement or the opportunity for improvement in a tool like that is so slight, just by nature of it. What MillMax is going to do, it's not a miracle worker, but what it's going to tell you is what that tool is capable of. And in a tool like that, we can tell you what it's capable of, but it may not be too much more capable than what you're already operating. But again, that face mill that you run all the time, that 1/2-inch or 3/4-inch end mill that you run all day, every day, or on a lot of different jobs, those are the ones that challenge us to bring in to do a demonstration. And sometimes we find that the customer is already optimal. But what we also find is when we inquire with those customers and say, hey, you're running at 175 inches a minute, and that's what looks like with this configuration might be the best. We just found that in 15 minutes. And think back to when you started working with that tool and how many months or years you may have been working with that tool to get there. The ability for us to find that in that short order, think about what that can do for different and new jobs as they come out. So back to how to get MillMax. So we do a demonstration, and then what we look for in terms of how we've monetized this is we're not charging a service fee. We inquired with customers and collaborated to find what was the ideal way to launch this service. And you guys don't have money set aside to pay service fees for end mills, frankly. And so if we were to charge $1,000 or $2,000 or $5,000, almost like an HVAC repair person might show up, and it costs X amount for them to show up, and then they're going to quote you on how much it's going to cost to fix the HVAC. If it was a similar situation with MillMax, customers just don't have that kind of a budget set aside, and it's a little bit out of the ordinary. So we scrapped that idea, again, with the guidance from our customers. And the next one, we said, hey, listen, these cost savings that we're developing are agreed upon, virtually every time from our customers. Maybe we take a small cut of the savings that we get. So there's a skin in the game for both sides. The better we do, the more you save and the more money we can make on the service. And so let's say 10%. And we kick that around. If it was a $10,000 cost savings and saved you 10% or charge you 10%, then we would have an invoice of only $1,000. And frankly, the software and the technology and the value it provides is well in advance of that. And that's frankly not enough for us. We might pay that, but again, that's money that you didn't budget for. Well, what if it was $100,000 cost savings? Would you really give us a $10,000 check for 15 minutes of work? And you may or you may not, but a lot of customers are like, yeah, I don't think so. Even though the value is there, it's a tough pill to swallow. So we went back to the original basics of doing business and to say, we just want to earn your business. And so what we do is ask for incremental sales, stuff that you already buy, but you may buy from somebody else, a competitor of ours or somebody else, and say, look, we want to become your end mill supplier, or your tool holder supplier, or your fluid supplier, or your face masks or gloves, and any of those kind of things. And if our price is commensurate with what you're paying for those items, transitioning that business to MSC doesn't cost you anything more, and you get access to MillMax. And that has really been applauded by our customer base, and that's the way we do that. And so your salesperson, we'll talk to you more about that if you're interested. So we typically end with these questions, and some of them have been asked here regarding MillMax that we may have heard and may not, and do a speed round here because of the time. Does it work on things other than milling products? And frankly, the answer is no. This is really made for milling, and we learned earlier that milling is different than all other types of operations by virtue of some of the cutting edges being in the cut and some are not. That said, if we need to test and see how much a spindle is vibrating, or in a lathe application, maybe a long cylinder or a boring bar that's hanging way out, there's advanced techniques that we have yet to learn that we may be able to apply in the future. But I would look at this right now for just milling. We already talked about live tooling, so somebody gets a check mark for that question. Does it work in composite materials? Boy, we're seeing so much of a water raising and across the country with customers machining composites. The answer is yes. MillMax is prepared to work in just about any material out there. I haven't found a material that it won't work in at this point. We learned about the fact that it works on solids and indexables equally. What about the part? How does MillMax take work holding into account? So you might think that your work holding solution may not be adequate enough and feel like the part is moving. And what we found is when you introduce stability in terms of the milling cutter to the workpiece, you actually impart stability on the workpiece. So the overwhelming, insane percentage of the time that it's not the workpiece, it's not the workpiece's fault is what we find. If you introduce unstable parameters to a workpiece, it's going to impart instability on it. It might feel like it's the workpiece. In most cases, it's not. We have a way to identify that, but it's less than 1% of the time is what we're seeing right now, that chatter being caused by workpieces that aren't being held tightly enough. Some tools have, and holders have emerged. We've actually found in a lot of cases a change in tool holder has more of a positive influence on higher operating parameters than the end mill itself. And so, seeing things like shrink fit holders as compared to hydraulic holders, or of course side lock end mill holders, we can do comparisons and contrast that. But there's also certain types of end mills that we're seeing are outperforming others. You have to tap a tool every time it's changed? Absolutely not. Unless something significantly changes with that setup or with your spindle. If you crash the spindle, then we should probably come in and retap the milling cutter situation. But so long as you're replacing it with the same end mill and it's sticking out the same length and the same holder, then you don't need to tap a tool again. Is it better suited for production shops rather than job shops? No, it is applicable for both from a production shop perspective, and I'm going fast right now because of time. But from a production shop perspective, the faster you can go, and if I can rip a couple seconds out of a cycle time, that could mean tens of thousands, if not hundreds of thousands or more in revenue or profit improvement. Of course, we would all recognize that, but for job shops, is just as important. And I would argue it is, and potentially even more so. So if you're doing a few pieces, but in advance, because of MillMax, exactly how to program this thing and to not be making scrap. We find job shops, I was reading Modern Machine Shop this morning, as a matter of fact, that job shop scrap rate can be on average somewhere in the 10 to 15% range. Imagine if you were able to significantly limit that. And all of that time and all of that energy and all of that cost of that raw material was all saved. If you're using MillMax and using the service, then you're going to have less scrap, and you're going to have more knowing and higher speeds, which means more jobs. So, for job shops, it's just as critical. So that's what we have. Ron, are there any final questions? Went slightly over this time. I apologize.
No, that's it, Jamie.
Okay, so folks, listen. I'll have you guys get back to what you were doing or the task at hand. We will be in touch to see if there's any interest in setting up a demonstration. I appreciate you attending, and I hope you guys have a great weekend. Thank you.
Thank you again for joining us today. This concludes today's web conference. You may now disconnect. Have a good day.